Hey guys, welcome back. This is integration by parts. So the most important thing about integration by parts is to identify them. In the first example that I have here, we're not going to do integration by parts. What we're going to do is we notice that this is a product. And the next thing that we notice is that it's an exponential function and an algebraic function. So take a look at the exponential function's exponent, x squared. This differs by 1 with the algebraic function. So what we can do in this case is we can set u equal to the exponent, du dx is equal to 2x, du over 2x equals dx. When we come back here, that's an integral sign, that's the x, that's e to the u, and dx becomes du over 2x. What happens in this case is that our x's cancel, and so you factor out this 1/2 e to the u du, and then that's a basic integral. You just have to go back and plug in u to be x squared plus c. So that was great. So in this case, we didn't have to do integration by parts because the exponent differed by 1. In our next example, we have to do integration by parts because the exponents have the same power and it's a product. So what we want to do is we want to remember our acronym LIATE, LIATE. L stands for natural log, I stands for inverse trig, like arcsine, arctan, arcsecant. A stands for algebraic functions like x squared, x to the third. T stands for trig, and E stands for e to the x or any exponential functions. So what we do is, since this is going to be A and E, we're going to put the x here, and we're going to put the e to the x here, dx. We're going to take the derivative of x and put it here, which is 1. We're going to take the integral of e to the x, and that's e to the x. I'm going to put a dx there. What we do is once we are done, we make a check. And your answer to this, I'm going to have to erase the top. So you can always pause the video. You can always pause the video and take down notes. You can also try the problems before I even do them. So what I'm going to do here is I make this check, and so this is actually equal to the first part. Let me get a different color. Here, x times e to the x minus the integral of the next part. Notice we're not done because we still have an integral. So do we know what the integral of e to the x is? It's just e to the x. So this is our final answer. So this piece here is equal to this. So what we do is we put the algebraic function here, the exponential function here. We always take derivatives, we always integrate, and then you're done. So let's try another problem. This is a product, so it reminds me of integration by parts, but just like the exponent differed by 1 when we were talking about exponential functions, the angle differs by 1. This is x squared, this is x, so that tells me it is not an integration by part. So what you do here is you just set u equal to the angle, du dx equals to 2x, du over 2x is equal to dx by cross multiplying. That goes here, that goes here. You changed x squared to u, dx becomes du over 2x. You factor it out by getting rid of the x's, and you say, who gives me cosine? Well, that's just sine u. So 1/2 sine x squared plus c. You're done. That's a basic u substitution. That's because they differed by 1. So be careful. In this case, it's a product and the angle doesn't differ by 1. Once again, pause the video if you need to. So this is algebra, this is trig. If you take a look at LIATE, which was up here, algebra goes on the left of trig. So we're going to put an x here, we're going to put a cosine x here. We're going to take the derivative, that's 1. We're going to take the integral, that's sine x. You're going to make your check, and that's going to be x sine x minus the integral of sine x dx. So x sine x, and the integral of negative sine is positive cosine. Or the integral of sine is negative cosine, which is a negative negative. So that's all. That's your answer there. So I hope that's okay. Okay, in our next and final example for this video, because I didn't want to make this video too long, I also see that this is an integration by part. The reason why I see a product, I know my angle doesn't differ by 1, so I have to use the integration by part. But what happens here is this algebra and trig, the algebra has an exponent bigger than 1. It's going to be a lot of work when your exponent is bigger than 1. So what you want to do is a certain method. You take the x to the third here, and you do cosine 4x here. And you take the derivative of this until you get to 0. So this is going to be 3x squared. This is going to be 6x. That's going to be 6. And that's going to be 0. The integral of cosine angle is sine angle divided by the derivative of the angle. So that's a fourth. The integral of sine angle is negative cosine angle divided by the derivative of the angle, which is a 4, but there's already a 4 there, so 4 times 4 makes 16. The integral of cosine is going to be positive sine, so that's going to be sine angle divided by 4, and so there's already negative 1 over 16, so that's 1 over 64. And let's see if that's enough. I think we need one more, but let's just see. We're going to do arrows, this times this, this times this, this times this. Yeah, we need one more, okay? So sorry about the numbers. So the integral of negative sine is positive cosine divided by 4. And 2 to the 6, 2 squared, 2 to the 8th, so that's going to be 256. Sorry about my math. I just did it that way. So my final answer for something like this would be x to the third times 1/4 sine 4x. So that's the first part. The second part will be, and you also have to do plus, minus, plus, minus, plus, minus, okay? So this is a different type of method, so that's fine. Negative times a negative is a positive, okay? And then positive times that negative is going to be 6 over 64. I'm not going to reduce anything right now. Times x, and then sine 4x, and then 6 times 1 over 256, but it's a negative because of this person here. And plus c. So that's how we do, 256 here. So that's how we do this type of problem. So we should use this method when x is bigger than 1. Could we use it when x is just 1? Absolutely. Let's see what happens if we did that. So I'm just going to go right back here. This is my answer. I'm going to go x e to the x. The derivative is 1. The derivative is 0, plus, minus. The integral is e to the x. The integral is e to the x. So now we're just going to go this times this, which is this part here, minus this times this, which is this part here. So it works even with x to the first power, okay? So that's how we do integration by parts, but come back for the next video, which has more examples.